Hello, this is Brad Chandler with Allegheny Educational Systems. And this is a demonstration for the Artec 3D scanning systems. What we're going to use today is an Artec 3D scanner called EVA. If you'd like to learn more, you can visit us at www.alleghenyeduSYS.com. Today, we'll be showing you some applications for an EVA, how to use it through the software that comes with it, which is called Artec Studio, and the workflow. So let's get started. Artec 3D scanners are used by a wide variety of industries to capture data or geometry that would otherwise be hard to create in standard CAD software packages. Say, for instance, you want students to design a GoPro mount specifically for this style of bike helmet. By scanning with an Artec scanner, you can capture the exact geometry without having to draw the entire model in a separate CAD package, saving time and allowing for exact form, fit, and function, just like in industrial design and manufacturing applications. Anatomical metrics for health, prosthetics, and animation can be gathered with Artec 3D scanners, as well as fragile specimens for sciences and education. And of course, fine arts, sculpture, and architecture. All of these applications benefit from the ease, portability, and speed of 3D scanning with Artec scanners. Essentially, the Artec scanner uses photo frames and stitches them together to capture surface data. The Artec Studio software then stitches or registers all of those frames together to form solid volumes. For this demonstration, we're taking a Southeast Asian inspired sculpture with a headdress and scanning both sides and then fusing those sides together in order to create a fully watertight mesh. We can then save that as an STL or ASC, OBJ, or other file formats that could be taken into CAD software or animation software, or software for 3D printers in order to replicate this sculpture. And here's how we did it. From the software, I can click Scan. When I click the play button at my thumb, it's going to give me a little bit of a preview. As soon as I'm ready and I can check my distance with the wave pattern on screen, I'm going to be in the green as much as I can. I'm going to hit play one more time at my thumb, and now I can see that it's capturing data. However, there's so much detail and a bit of noise in the background with my backdrop. It's a little hard to tell what I'm capturing and what I might be missing. Therefore, there's another tool built into the Artec Studio software that I can use. So I'm going to stop this scan with the stop button right there at my thumb. Software is going to begin processing the first scan already. And you can see I have lots of background in here. Okay? It's also still very hard to tell, even though it's giving me the exact color of the object. It's kind of hard to tell where I may have missed some details. So what I could do is turn on this function, real-time fusion. As long as I have a separate video card, I can use that function. So this time, I'll scan the same object, hit play. It's going to jump to preview. I'm going to hit play once I get my distance, hit play one more time. Now, I have a much better view in real time. Trying to make sure that I get all of the angles of the object. And then hit stop. Now that we have the fusion scan, we can see my first scan here, my second scan, and the fusion portion. This was simply a visual to help us with the demonstration and to help us see what data we're capturing. This is not the actual data that we want to use to process, so we can immediately get rid of that scan. We can also turn one scan on or another scan off. We can also turn scan colors on and off so that we can see a little easier rather than the realistic color. Okay, there are my first two scans blended together. I'm going to ignore scan number 1, simply go with scan number 2. Since I'm going to have to end up aligning the back with the front, I may want to make sure that I overlap portions of the back of the scan with some of the same areas that I scanned from my scan number 1. So I'm going to hit play. Going to hit play again. I'm not concerned at all about the objects that I'm picking up in the background. I can certainly delete those later very easily. And stop. That is going to process again. And now I have two sides of my sculpture. Now I have multiple scans that I can review. I can get rid of the fusions right off the bat. Those are simply my previews. Because I've deleted several, it's IDing them as 1, scan 1, 2, and 3. But here it shows 1, 3, and 7. I can turn them on individually, change the color, so that I can see it a little easier. Now, in order to help processing time, in order to make things go a little smoother, I'm going to get rid of a lot of this background data. So I'm going to zoom out. I could switch right over to Autopilot. Or I could go into the editor and use some erase tools. Autopilot will take me right there, so I'm going to choose that. Autopilot is sort of a wizard that walks you through some of the basic steps to using the Artec Studio software. I'm going to say OK. Select the scans to create the model. I'm going to use all the scans. Scan 1 and Scan 2 were very similar, but they might actually help each other out and fill in some areas that I may have missed in either one. So I'm going to select all. I'm going to hit Next. Model creation. Typically you have good or bad, quality, scan quality, good or bad for texture. Texture, when they refer to that, geometry is the actual surface data. Texture is more the color data. So if we're not using texture or going to save any of that data, that's going to save us on processing time if we turn that off. Okay? Our object is rather somewhere between small and medium. We could call that medium. And we always want to end up with a watertight surface so that we can take that over to a 3D printer. I'm going to leave everything else alone. Say Next. Editing. This is where I'm going to be able to trim away a lot of the unnecessary background. Say Next. Gives me a couple of these tools, takes me right into the eraser. I'm simply going to grab a lasso. I'm going to hold my Control and my left mouse button in order to draw right around everything. And I can pretty much get all of it here, almost. It's going to highlight most of that. I can say Erase. That's good. I can get rid of some of this other stuff, but that's just a little piece of the table. I'm not even going to worry about that for right now. So I'm simply going to say Next. Alignment. It is going to try to align the surfaces automatically. Since I have the last scan turned completely 180 to the front half of the scans, it's probably not going to align these automatically. However, if you were to scan and move yourself all the way around the object, then it will typically automatically align. So, it didn't align correctly, but that's okay. It says some scans remain unaligned. Do you want to rescan the object? No, I want to align the scans manually. It's going to be really easy. It's going to open up all my scans, but it's only going to show the first one and the second one, or only one at a time. Okay? So those two look aligned. I can say Align. Then I can open up the third. Now, this is way off. However, what I can do is use a combination of Control or Control-Shift and my mouse buttons in order to either orient my view, or by holding Shift, I can orient the scan number 3. Orient my view a little bit, orient the scan. Okay. What I'm trying to do is get it to a point where I can, from the same perspective view, such as this, I can actually see several matching points. Okay. So what I'm going to do is I'm looking at, here's the front of the face, here's where the front of the face would be. There's an eyebrow ridge, there's an eyebrow ridge. So I could say this is one point, and this is the same point. I can go up top here, probably find where that V comes over. That's the first V of kind of that headdress. And I'm going to look at the first V of the headdress is somewhere about there. This does not have to be absolutely perfect. It just simply needs to be very close. Kind of the elongated earlobe portion, that little indent. I'm going to look at that little indent right there. We say align. That aligned pretty well. The little dark patches are places where either the object was too shiny and it was having trouble capturing some of that surface data, or I just missed it. Say, for instance, under the neck here. But that is going to automatically fill in and smooth in under the power of the software. So that looks good to me. I can come down here and say apply. And now it's going to run through some registrations. Basically, there are various ways, all of the frames of the scans within each scan, and then from one scan to number 2 scan to number 3 scan. And there we go. The model is finished. Say OK. I can now look around at the model. I can even compare, in some cases where there's damage to the sculpture, that the scanner even picked up certain marks. Looks good, nice and smooth. Filled in any holes. Now, I do have this large blob at the bottom because we didn't actually scan. I didn't actually take the time to scan the base very well. What I can do, however, is still edit this scan, or this fused scan. I can go to Editor, I can go to the Eraser tool, and I can use this flat surface here, or the flat surface of the desk, to create a cutoff plane. So in order to get rid of all of this extra stuff, I can go to the Editor, Eraser, hold Control, and use this to create a surface. Now I can hold Control and Shift and move that surface up or down so that I have a nice flat, straight surface with which to cut everything else off of. Now I simply have one little hole at the base of the neck here. Maybe I want to clean around that edge. I might go to the eraser tool, 3-dimensional, and I'll get a little stylus here. I'll cut around this edge and erase. But there's a danger that I could erase through the entire object. So I have a hole here. What I'm going to do is go over the eraser tool. I can choose 3D, and I can simply erase a little bit around this edge. As long as I stay on this surface, this stylus should end up only cutting away under here. I can check to make sure I didn't go all the way through the sculpture. Turn that around. Then I can go over to edges, and it will find this hole for me. I can select that hole. And of course, for 3D printing or processing in other software, I want to make sure that this object is watertight. So I'm going to say fill holes, and it's going to fill that right in. I apply that, and now I have a base. Now that I have my finished piece, I'm going to go to File, Export Meshes, and I can save this as any of these file formats. I'm going to save it as an STL. Now that it's saved, I could open up some .3D printer. I can open a 3D printer software package. I can choose a specific printer. I can bring my STL file in. Sculptural head. And there it is. Now, it's not going to come in at the right orientation that I'd like it, so I can simply orient that around whichever which way. And if I process this part, you can see that it's a fully watertight STL, meaning that this file would not need any other cleanup, any other processing in any other software if you simply wanted to replicate the object. As you can see, the model and support material of this Stratasys Dimension machine using Catalyst software has processed the STL from the Artec. I can add it to my pack and simply send it to my machine. I hope you've enjoyed this demonstration of the Artec EVA 3D scanner. If you have any other questions, please feel free to contact us at www.alleghenyeduSYS.com. For educators from Pennsylvania, New York, and New Jersey, we can also help with equipment and software for all of your STEM, Fab Lab, Makerspace, and career and technical needs. Thank you for watching. If you'd like to learn more about any of our products, you can visit us at www.untitled.com.